What's up everyone, welcome back to my channel. Today we're going to look at the following trigonometry expression. So in most of trigonometry classes, we have learned the Pythagorean identity as well as the identity between the trigonometric functions, such as the double angle formula as well as half angle formula. Also trying to convert from the square of a trig functions into a linear trig function, such as sine² in terms of sine to some angle or cosine of some angle, as well as cosine² into sine of some angle or cosine of some angle. But other than that, usually we will not learn or trying to push a little bit more, including trying to move to a higher power, as well as for other trig functions such as tangents, cotangents, secants, and cosecants. So today we're going to first trying to find out the expression of tangent² of x and cotangent² of x in terms of some linear trigonometric functions as our expression. So in other words, we'll try to rewrite tangent² in terms of tangents of some angles that might not be x anymore. As well as for cotangent², we would like to see if we can convert it into something that is in terms of cotangent of some other angles as well, hopefully. And of course, sometimes it might not work, and we might actually need to use some other trig functions such as sine or cosine, or maybe secant or cosecant to support us. But anyway, let's move on. So for the first one, we have tangent². And where can we actually find the tangent² and the formulas that we have already learned in trigonometric functions? Well, the best that we can think of is actually from tangents of 2x. So, or sometimes you might use 2 alpha or 2 theta, depends what your teacher would like to use in the class. But the double angle formula for tangent function is saying that tangents of 2x, or again, is a dummy variable, can be rewritten as 2 times tangent of x all over 1 minus tangent² of x. Okay, and of course you can just try to use sine of 2x over cosine of 2x and throw in to do the division and simplify it into this form, and you should be able to get the same results. Then now we can see that on the right hand side there is actually a tangent² of x containing, which is something that we want to find. So what we can do is now we're going to cross multiply to get 1 minus tangent² of x times the tangent of 2x, and we'll just write it like this, equals to just the numerator, 2 tangents of x. So of course, in order to isolate the tangent² of x, we can just divide by tangents of 2x on both sides, such that we only have 1 minus tangent² of x, the first factor remaining on the left hand side, where the right hand side will now become 2 times tangent of x over tangent of 2x. And finally, we can just try to move the tangent² of x to the right hand side and then put the fraction to the left hand side by subtracting the fraction, and then add the tangent² to the other side to give us tangent² of x is equal to 1 plus the fraction, excuse me, not plus, 1 minus the fraction, which is, if we want to put them together, we'll get tangent of 2x minus 2 times tangent of x all over tangent of 2x. And that is the final result. Okay, let's move on to the next one. Okay, so as we found out the expression for tangent square of x, now we're going to move on to find out the expression of cotangent square of x. And we actually would like to use the same formula for tangents of 2x. And this time, we're going to use the identity that says tangent is the reciprocal of cotangents as long as they have the same angle. So if we want to find out cotangent of 2x, we can just take the reciprocal of the right hand side, which means we are going to flip the fraction, and we'll be able to get the formula in terms of tangent at this moment. But of course, we don't want to end up with tangents because we start off with cotangent. What can we do? We're going to divide everything by tangent square of x because that's the highest term. So in that case, we will now get something minus 1 here, and then for the first part, 1, it will become 1 over tangent square. But again, 1 over tangent is just cotangent, so we actually will end up with cotangent square of x minus 1 all over 2 times cotangent of x. And again, because we're actually dividing by 2 copies of tangent, 1 copy cancelled out, we still have 1 copy remaining in the denominator, so we have 1 over tangent, which is, again, equal to cotangent. Then we can now try to use this new expression to help us find out what cotangent square of x is in terms of cotangents only. So on the right hand side, we already have cotangent square of x minus 1 all over 2 times cotangent of x. Good. And on the left hand side, we have what we started off, cotangent of 2x. So in order to isolate the cotangent square of x, first we need to multiply the denominator to the other side so that there will be no more fraction. And we will get 2 times cotangent of x times cotangent of 2x. Great. And finally, we just need to bring the 1 to the other side by adding it. So, ladies and gentlemen, this would be the expression of cotangent square of x in terms of the linear terms. Okay, that's it. So for the other 2 expressions, which are secant square of x and cosecant square of x, I'll leave it for the next video. Okay, if you enjoyed this video, please don't forget to like, and you can subscribe to my channel so that you will find more of my other videos. And if you have any thoughts, you can leave your comment down below. I'll see you guys in the next video.